Hello viewers, welcome back to my YouTube channel Defacto Techie. This is Deepak and today we will see about PySpark. So PySpark is nothing but an interface for Apache Spark in Python. Actually, PySpark is written in a Scala platform using JVM, but in today's world, most of the developers know Python well and they feel easy to code in Python. That's why Apache Spark team thought of making an interface for Python developer to use their service Apache Spark, and after that PySpark comes into the picture. So today we will see about PySpark, Apache PySpark. Let's begin for today's agenda. What is Spark and its architecture? We'll look into it. What is PySpark? That is the interface of Apache Spark in Python. Why do we need it? Difference between Hadoop and Spark, and can we even compare this Hadoop and Spark? Is it a valid comparison? Difference between pandas and Spark, maybe this I will take in different video. Application of PySpark and notebook, so our notebook demo. Okay, so this will be the agenda for this tutorial on Apache PySpark, and we will see it in coming videos. This is a simple diagram of data flow from a storage to CPU. When I'm saying a storage to CPU, I mean to say from hard drive to RAM to processor. Okay, so everyone I believe is familiar with this set of diagram, set of system that you are looking at. This is hard drive, right? This can be an external hard drive, pen drive or CD drive, and this is RAM. This is our processor, which we can call CPU, like if i5, i7, AMD, etc. So this structure exists in every system. Hard drives are generally slow, low cost and non-volatile, whereas if we see RAM, it's generally fast, costly and volatile in nature. Each time if we execute any operation, that means we are giving instruction to this processor, right, or CPU, to process the data, and that data is in hard disk. So what happens here is data flow from hard disk to RAM, from here to here. Then CPU perform operation on the data present in RAM. Then CPU, this processor, perform operation on the data present in RAM. It could be any operation, read or write, any operation. So what I mean to say, CPU cannot perform any operation on the data that is present in hard disk. Data should be in RAM because it will be a slow process and time consuming process to find the data by indexing in hard drive. Clear? So to process any file, whether it's a PDF, XLS, any file, text file, it should be present in RAM. So size of RAM becomes important here. Size of RAM, I believe, must be greater than size of file. Else what will happen? Your system may freeze or collapse. So thinking in practical way, size of data may be greater than the size of RAM. Size of data in today's world may be greater than the size of RAM, because size of data may comes in TB, right? But RAMs, if we see, it's generally for our system it's 4 GB, 8 GB, 16 GB, that's it. Okay, So because in real world data may be in TB, I'm saying, okay. So at this point of time, we will have to think differently. We will have to use something like cluster environment, if you have heard it, distributed environment, or parallelization, so that we can distribute our work to different system, different nodes. We will see about this in coming videos. So main thing I am interested here to say is that big data is the reality in today's world. Means data is big nowadays, and big data is the problem. Then I'm saying Hadoop is the solution. Clear? Google released a paper called GFS, Google File System, in which file is stored in distributed manner. After some time, Google released a MapReduce function paper, but Google has never implemented it in any application. But after some time, Yahoo implemented it is an app. Yahoo implemented and created a new system called Hadoop. Sorry for misspelling. Hadoop, map and reduce concept is used in Hadoop. This is a Hadoop cluster which typically looks like you can see on your screen. In these, there are mainly three components: a storage unit, compute unit, and a resource manager. For storage units, they use HDFS, Hadoop Distributed File System. For compute engine, they used MapReduce, and for resource manager, Yarn is used. So if you see this diagram, this is Hadoop master slave architecture. Suppose this is a master node and we are giving it 20 TB of data to process and to perform any operation. What it will do, it will divide those files in different slave node, and task tracking, data node, map and reduce, all thing will happen in slave node, right? Suppose 5 TB, 5 TB, 5 TB, 5 TB here, and again it will cluster all and give back to master node. Now Apache Spark has been discovered, and I will just show you how and where this Spark framework fit in Hadoop cluster. It was a cluster of Hadoop that I was told you, and this is a Spark cluster. This has replaced MapReduce application. This is MapReduce application with Apache Spark. We can use same Hadoop storage system. This is Hadoop storage system, HDFS, and resource manager. Okay, this is resource manager. You can see here Yarn, and here also Yarn. Only changes here in compute engine, changes has been made. So we are not replacing Hadoop with Spark, I'm saying. So if someone asking you to compare Hadoop and Spark, it's not a valid comparison, because we are not replacing Hadoop with Spark. Instead, we are replacing only in the compute engine of MapReduce with Spark, correct? With Spark. So whole Hadoop system is not replaced, only MapReduce is replaced with Spark. So comparing Hadoop and Spark is not a valid comparison. Yes, if we compare Spark with MapReduce, it's a valid comparison. Okay, what is a Spark? It's a fast real-time processing framework. When I say framework, it's a platform for developing software application written in Scala. I have already told you. For Python interface, Py4j library is used. By using Py4j library, Apache Spark has been written in Python to provide interface for Python developer. In-memory computation, lazy execution, parallel processing. This part we will see in next video. I will take this slide in next video and explain each and everything. For now, just take an overview of this slide. Apache Hadoop MapReduce was performing batch processing only. Earlier only batch processing was being performed and it lagged in real-time processing features. Spark does batch and real-time processing both. It leverages Apache Hadoop for both storage and processing, correct? It uses HDFS Hadoop file system for storage, and it can run a Spark application on YARN as well. It's clear, okay? Only changes is made between these two remain the same. That is what I am telling. So Spark can load data directly from disk, memory, other data storage technologies such as Amazon S3. This is a cloud technology, very important. Hadoop distributed file system, HDFS, HBase and Cassandra. Okay. Thank you for watching this video. In next video, we'll come up with this slide again. What is a Spark? What is PySpark? And what is the difference between PySpark and Pandas? And many more agenda we will look in coming videos. Thank you for watching this video. Have a good day, viewers.